Good morning, student. Today in this class I will discuss about another very important device known as meter bridge. It is based on the principle of Whetstone bridge. Whetstone designed and bridge which is very useful to find the value of unknown resistance. What this bridge is all about, students see on the screen. It is a combination of four resistance in the form of bridge. Can you see it? Across the bridge, one side a cell is connected and another junction galvanometer is connected. But remember, student, in the same junction the cell and galvanometer should not be connected. Even they may be interchanged, but they should not be connected at one junction. At one junction cell, then the other junction galvanometer should be there. It is a combination of four resistance, and when the current flows through the galvanometer, the bridge is said to be unbalanced. And if the galvanometer currents become zero, suppose by some arrangement, then the bridge is said to be balanced. So when the bridge becomes balanced means Ig, remember student, galvanometer current becomes zero. That time if I apply Kirchhoff's law, so I have shown it here, I will get this type equation, I1 upon I2 R3 upon R1, and another loop I will get equation I1 upon I2 R4 upon R2. And if we compare these two, you will get R1 upon R2 is equal to R3 upon R4, or R1 upon R3 is equal to R2 upon R4. See the student figure once again, where the R1, R2, R3, R4 is there. Means either of the ratio, R1 upon R2 or R1 upon R3. Either of the ratio, if they comes out to be same, then the bridge is said to be balanced. And if the bridge is balanced, out of the four, if you know the three resistance, you can find out the value of fourth resistance. So this is how the scientist helped us in designing a method to find out the value of unknown resistance. But this method was quite tedious. It was not convenient because every time we have to take out the pair of the resistance, unknown resistance, again you connect another resistance, again you have to check whether galvanometer current is zero or not. So the advancement of this came as a meter bridge. Meter bridge is an instrument based on the principle of Whetstone bridge. It is used to find out specific resistance of a material. It is also used to find out unknown resistance, student. Now I will show you the construction of meter bridge. Meter bridge on a wooden board, student. One resistance wire is there, which I have given name in this figure as AB, student. Okay, AB is a resistance wire made of Ela. It is fixed on the wooden board. Now on the upper part you can see, student, in the some strips you can see, student. They are known as conducting strip. They are usually made of copper. And you can see there are two gaps where I have connected two resistance R1 and R2. Near R2, student, I have written resistance box. I will tell you what this box is about. Resistance box is an arrangement in which I can add the desired resistance of my choice. How it is helpful, I will show it. Now you see, student, other part of the circuit. We have a galvanometer and then we have a jockey, which I have shown by an arrow touching the wire AB. So this is another form of Whetstone bridge, student. But in this the advantage is that we don't have to take out resistance and connect. We can adjust it very conveniently. Now student, this becomes a Whetstone bridge. You can compare the two figure. The above figure which I have drawn in the Whetstone and this meter bridge. How the four resistance are coming, you see R1, R2, and the jockey where it touches the wire and the galvanometer shows null deflection. That length is measured L. And remaining length is 100 minus L because the wire AB is of 100 meter student, 1 meter, student. That is why it is known as meter bridge. The length of the wire taken is 1 meter, student. Now how will you calculate R3 and R4? Suppose the R3, the balancing length is L. I will apply the formula rho L by A. Similarly R4, again the same formula, but the length is 100 minus L. And if I divide R3 upon R4, see, student, what I am getting? L upon 100 minus L. Now I will say you something about resistance box, student. In resistance box on a wooden board, okay, student, there are conductors and between the two conducting strip a gap is there. In that gap the brass keys are there which are inserted or which can be taken out, which I have shown it in the figure. And below the brass key, below it I have shown a resistance. Suppose I take out the brass key, then the wire will flow out through that resistance, and if I connect the brass key, the current will flow straight. This means if I take out the brass key, actually I am adding resistance to that circuit. On the brass key, the values of the resistance are written. Say I have written it 5. So this 5 will be written on the brass key. So when I take out that brass key, the current will flow through the 5. If I want to make it 7, I will take out two resistances, two brass caps, 5 and 2. Like this, there are many different arrangements are there of different values in that resistance box. 5, 10, 15, 2 ohm. Even infinite is there. There is air gap is there. Means by the help of this we can add the desired resistance of our choice. What you have to do is you take out the brass cap where that particular number is written. If I take out brass cap written 10, this means I have connected 10 ohm resistance. If I take out two brass cap 10 and 5, this means I have connected 15 ohm resistance, which is shown in the meter bridge as a R2 students. Here I can add the required resistance of my choice. Choice means which is available in the resistance box. So when the bridge is balanced student, again the same principle. R1 by R2, R3 by R4. R3 by R4 I have already calculated. So ultimately student, I will get the formula. Now how to measure unknown resistance? As I just now told you, create R2 in RB, okay? That by taking out the brass key. With the help of jockey, look out for distance L so that current I becomes 0, means galvanometer current becomes 0. And I have to note it the value of L. Similarly, again to take the second reading, I take second values of R2. Again I will see the null deflection. But the null deflection should be always adjusted between 30 to 70 centimeter. This will increase the accuracy of the meter bridge. The length should be adjusted such that the null point comes between 30 to 70 centimeter. Because student, the formula which we have utilized R1 by R2, they are the resistances, but at the end there are copper strips. It will also have some resistance which is not taken into account. So if I get the null point in between, that resistance which is not taken into account, they will cancel in the ratio. That is why null point must be adjusted between these ranges which is given 30 to 70 centimeter. Then student, you have to make a observation table which I have drawn it here. See, R2 which is choice from the resistance box. I have to find out balancing length L. Similarly, I have to add different R2 and different L I have to find out. L means student null point. And then 100 minus L I can calculate it. And then the formula which will come out to be student C. Same formula, Whetstone bridge. R1 upon R2 is equal to R3 upon R4. So student, R2 is known from resistance box, L is known from the experiment. 100 minus L you can calculate. So you can get the value of unknown resistance. Similarly, you can student calculate the specific resistance also, because formula for specific resistance is rho L by A. So L length you will measure by scale. To measure the area, you have to find the diameter of the wire. Area A pi r square. From there you can find out area. So this method helps us to find out the specific resistance also, student. Students, some precautions are always taken in electrical experiment. The current should be made on only when the readings are taken. And the joints where the wires are joined, anywhere where the joints are there, connection, this should be thoroughly cleaned, student, because as you know, copper, it will form oxide, and copper oxide, it will have its own resistance. So circuit must be thoroughly cleaned at the joint points. Similarly, the null point should be adjusted between near the center of the wire, so that the end resistance which are neglected, they can be, student, cancelled. Now see, student, meter bridge, you can also find out you can also prove, not find out, prove the law of combination of resistance and parallel. Suppose student I have two resistance. One is of 2 ohm and other is of say 4 ohm. So 2 and 4, if I connected in series, what is the value student? 6 ohm. Now see how I can verify it. See, what I will do is, in place of R1, I will first connect 2 ohm. Okay student, I will find out, I will connect 2 ohm resistance and I will find the balancing length. Second, I will connect in place of R1 4 ohm. Again, I will find the balancing length. Okay, student. Then I will connect in place of R1, 2 and 4 ohm are in series, I will connect it. So this student, what I am talking is I will get the experimental value. Okay, that 2 and 4, it is a written value. So first I have connected 2 ohm in place of R1 and I have calculated the experimental value of R1. Then I will connect 4 ohm in place of R1. Then I will connect 2 and 4 ohm in series and I will check the experimental value which I am getting. So as I already know 2 and 4 comes out to be 6. So final result should come out to be near about 6. So exactly 6 it will not come out. Similarly student, you can prove the law of combination of parallel. How? Similarly, in place of R1 you connect 2 and 4 ohm in parallel, you connect and see the experimental result by finding L and 100 minus L. You calculate the value of R1 as calculated before. Now the R1 means now we have two resistors in parallel, say 2 and 4. Again you can check the mathematical formula value and the experimental value and you will see that it is verified. Those formula student, R is equal to R1 plus R2 or 1 by R is equal to 1 by R1 plus 1 by R2, they have been obtained by these experiments only. By performing these experiments, those formulas were generated. It is not that first formula came and then we have done the experiment. From this experiment, those formulas were made. So student, from this we can do the three experiments. One, finding out unknown resistance and determination of specific resistance. Second, verifying law of combination of series and parallel. You can do it. What you have to do is, where I have written unknown, there you have to connect that resistance. Find the balancing line and calculate from this formula. See, R1 upon R2 is equal to R3 upon R4. That formula. R3 upon R4 is L upon 100 minus L. That will be equal to R1 upon R2. R2, as I told you, resistance box, you know the resistance. R1 is the unknown, you can find out. So there you can connect different resistors and then you can connect resistance in series also, and then you can verify whether the formula which we know, it is following the same as it is obtained from the experiment also student. So this is what the meter bridge is based on. Now student, I will solve one numerical of meter bridge. See, this is the question. R and S and balancing length L and 100 minus L. Student, balancing point is found at a distance of student 33 centimeter from A. The balancing length is at a distance of 33 centimeter from A. It is the first condition given. Okay student. Now see the Whetstone formula. R by S will be equal to L upon 100 minus L. This I have written. L is given 33.7 as it is a meter bridge. So 100 minus L. So this is the one equation which I got. Okay student, I am repeating it. R by S will be equal to L upon 100 minus L. And what is L? It is a balancing length. And value of L is 33.7 centimeter. Now student, second condition. If now a resistance of 12 ohm is connected in parallel with S. At S we are connecting a resistance of 12 ohm. So what is the resultant resistance student? Parallel formula. 12S upon S plus 12. Now the balancing point occurs at 51.9 centimeter. Remember student, this length is from the left hand side. Okay, means value of L. Again, based on the Whetstone principle student. 51.9 upon 48.1. How I got 48.1? 100 minus L student. 100 minus L. Remember I told you meter bridge wire is 1 meter in length. So L 58, 51.9, 100 minus that will give you 48.1. Now that is equal to R by S dash. Student, S dash, because now there is a resistance parallel. It is not S. It became S dash. Then I have substituted the value of S dash, student. Okay. So you have another equation in the form of R and S. Now student, if you substitute the value here, you will first get the value of S, and that will you just calculate and see, student, it will come out to be 13.5 ohm. And from here you substitute the value in 1, you will get the value of R. So can you see, student, how we have got two unknown resistance by this method? R and S both are obtained, and it is based on the principle of Whetstone bridge. And when the bridge is balanced, galvanometer current is 0, student. So this is, and one more thing, student, this in practical also it is there in our syllabus. You can write down the practical of meter bridge also. There are 3 practicals. One is specific resistance and determination of unknown resistance. Second is law of verification of series connection and parallel connection. And it is totally based on this formula, student. R1 upon R2 is equal to R3 upon R4. Means that ratios are same. And when it is same, means the bridge is at balance condition. Once again, I will show you the experimental setup, student. This is the observation table, R2, L and 100 minus L, and this R1 is the unknown resistance, student. Once again, I will show you the experimental setup. See, student, this is the meter bridge circuit. One gap means copper strip is there. In that gap I have connected unknown resistance. Right gap I have connected resistance box, and the lower side, you know it, that is a wire of 100 centimeter where the null point is obtained. So where the null point is obtained, the wire is divided into 2 parts. Okay, so what you have to do is, first, where R1 I have written, you have to connect one resistor whose value you don't know. Okay, and even if you know it, it is a written value. Okay, so you calculate R1. Say I have given an example, it is R1 is suppose 3. You connect R1 as a 3 ohm there. You calculate the value of R1 experimentally. It will come out to be near about 3 only. Okay, next, say you have another resistance of 5 ohm. Now you take out that 3 ohm and connect 5 ohm in place of R1. Again you find out balancing length and experimental value. You will get another value near to 5. Now, student, what you do is you connect 3 and 5 in series. Series means 1-to-1 connection. Okay, 1 terminal connect together, and the end of those 2 terminal you connect at R1. Okay, means in R1 you are connecting 2 resistance in series. That is becoming now R1. Again you find out the balancing line and you will get the value of R1. Now, student, you are getting the series combination value. Remember, you are getting the series combination value. Then you compare it with the actual formula and the experimental value. You will see the value comes out to be same. Next, what you do, student, you connect in place of R1 those 2 resistance in parallel. Say you have taken 3 ohm and 5 ohm, you connect it in parallel, and again you find out the balancing length. How will you find out balancing length? By taking out some resistance from resistance box. In resistance box there are variety of arrangement of adding different resistance, 2 ohm, 5 ohm, 10 ohm. Even you can combine them. Arrangements are there. You take out 3 or more keys out, brush keys out, those all in series will be connected. Now again, student, you find the value of R1. Remember, student, this is the value in parallel you are getting R1. Okay. Now the R1 will give you the parallel combination value, student. So you calculate the value of R1, and again you compare the mathematical formula with the experimental result. Like this, student, there are 2 experiments connection with the meter bridge, and remember it, it is based on the balancing method of Whetstone bridge balancing method, where the galvanometer current becomes 0. And one more thing, remember, to increase the accuracy of the meter bridge, the null point must come near about the center. You have to adjust in such a way, and only pass the current when we are taking the readings, and the wire it is made up of alloy such as manganese or constantine. And what is the property of alloy? It has low temperature coefficient of resistance. And what is the meaning of low temperature coefficient of resistance? The resistance will not change with temperature. That is the meaning. Very less change or no change. That is the property which alloy has. Okay, student. So we will continue with the similar concept in the future classes. Thank you, student.